Okay, let's talk about variables and units of measurement. So for the purpose of this lesson, I do have my notes in a Cornell Notes format so that you can see the objective and the essential question at the top. I want you to think of Cornell Notes as a bit like a book. So over here on our left side, we have our chapters. Those are kind of going to guide you through the parts of the book. And then we actually have the content or your main notes over here. These are your notes that you will be taking today. So again, our topic is variables and units of measurement. So I'm going to zoom in here so you can see that. I want you to write that in the top right corner of your notes. And our objective today is defining a variable and determining its appropriate unit of measurement by taking focus notes and using various tools to take measurements. So I'm going to walk you through my notes, and as I walk you through these notes, I hope that you will record those notes in your own notebooks as well. I'm leaving the date blank. You all are taking notes on a certain day, so you can go ahead and fill in today's date there. The essential question for today that you all should answer in the summary of your notes at the bottom is, what is a variable? And then our second question is, what is a unit of measurement and how do they help us solve physics problems? Okay, so let's start with the first part of this topic. What is a variable? I'll zoom in a little bit more if I can. So a variable is a letter or a symbol used to represent an unknown value. So I'll highlight that there. That is a key vocabulary term for you all to remember. So an example of a variable would be, S for speed, or using an A to represent acceleration, or P for momentum. So these are all examples of variables representing different values in physics. Okay, you all might be more familiar with using variables in math class, right? We use, if we're talking about a math equation, 2x plus 5 equals 10. Right, our example of a variable here in this case would be x, or we might also use variables y, right? So instead of x, we might replace that with a y, 2y plus 5 equals 10. Okay, so our variable there in this case is a y. These are all just examples of variables you might have used in the past. Again, it could be any letter or any symbol you want. You could pick your favorite symbol. It could even be a heart, right? I'm using the wrong tool there. Could even be a heart if you really like drawing hearts, right? 2 heart plus 5 equals 10. Again, it is any letter or any symbol you want to use to represent something that we don't know, right? Something that we are solving for. So we will talk about in the future examples of speed and acceleration and momentum as we go on in this class. Again, most of the time in physics, you will notice that we choose the variable with using the first letter of that value, right? So we use S for speed, A for acceleration. Sometimes we get a little bit funky and we use letters like P for momentum. That's usually when another letter is already taken. So you'll learn in physics, we use a lowercase m to represent mass. So we had to resort to P for representing momentum. Okay, moving on to our next topic. Okay, what is a unit of measurement? Well, a unit of measurement describes the amount of something. Okay, so for example, if I'm describing the length of something, I might say that is 10 inches, right? So we use inches to measure length. If you're describing how much time something takes, you might say seconds. It takes 10 seconds to do this task. Or if you're measuring the mass, right? How much space something takes up, how big it is. You might measure that in kilograms. Now, I want to make this point very clear, and that is to never leave what I like to call a number naked, okay? Do not leave naked numbers, and I'll just highlight this. This is another vocabulary term here. So what do I mean by that, all right? So if I'm asking someone a question and I say, how long is that ruler? And then they reply, it's 12. Well, I'm going to say 12 what? 12 centimeters, 12 feet. How long is a ruler? Okay, so always, always, always make sure you include your unit of measurement. So this is what we would call, if we just were to say 12, this is what we call a naked number. Okay, we do not ever want to leave a naked number. Okay, always make sure we include the unit of measurement there. So you will notice as we move through in our physics class, we will study a lot of these units of measurement, and these are designated international units of measurement, meaning that the world of scientists have come together to determine that these are going to be the standard units of measurement we use to measure everything, okay? Because it gets really, really confusing. We have one scientist in America using inches to measure length. We have another scientist in China using meters to measure length. So it's really hard to replicate and share ideas when we're using different units of measurement. So the scientific community came up with this idea of an international system of units of measurement. So we call these SI units of measurement. So the international standard unit of measurement for length is the meter. The international standard unit of measurement for time is the second. The international standard unit of measurement for mass is the kilogram. International standard unit of measurement for velocity is meters per second. So we represent that with an M-S. We will talk about that in future classes. All right, force is newtons, represented by a capital N. So we will study a lot of units of measurement here. I just wanted to draw your attention to those now as examples, but this is a standard system we will be using in physics class. Lastly, I do want to cover how we might use this international system unit of measurement to convert units of measurement. Okay, so I did want to draw your attention to how we use this system. We like to talk about this system in terms of scientific notation. So if we are starting with our base unit, let's say we start with a base unit of a meter, for example. As I said before, the meter is the standard unit of measurement for length, the SI unit of measurement for length. However, we could make these units bigger if we wanted to. You might have heard of the kilometer before. So I'll write that there. So we use this prefix, okay? A prefix means it comes before the root of the word. So we use kilo to represent that 1 kilometer, for example, is 1 meter times 10 to the third power. In other words, it is 1,000 meters in this case. So we can go up on the scale and we can go down on the scale. On the opposite side here, we might have a millimeter. So you probably have heard of a millimeter before. 1 millimeter is 1 meter times 10 to the negative third power. In other words, 1 millimeter is 0.001 meters. That is a millimeter. So if we want to convert between units here, these are the steps that we would follow for converting units. The first thing to determine is if you're converting from a big to a small unit or a small to a big unit. Now, I'm going to write off to the side of these notes, but if you do have room in your notes, I recommend you just write this next to these steps for this example here. So I want you to pretend that we are converting, let's say we're going from 5 meters to kilometers. So our first step is to determine if we are converting from a big unit or to a small unit or a small unit to a big unit. Well, if we look at our scale over here again, we're going from our base unit of a meter and we want to convert to kilometers. Now we know that 1 kilometer is 1,000 meters from this example here. So I'm going to say that we are converting from a small unit to a big unit. Okay. Now let's look at our second step over here. Our second step is to subtract the two exponents to find the difference. So if we have our exponents here, right, we're starting with our smaller unit of meters, which is our base unit. That exponent right there is going to be 10 to the 0th power. And as a reminder, anytime you have something to the 0th power, that really just means it is equal to 1. But for the purpose of this example, we'll just say that is 10 to the 0th power. And our kilometers, we go to our scale here, our kilometers say that it is 10 to the 3rd power. So I'm going to write 10 to the 3rd power over here. Okay, that is step number 2. The third step is to move the decimal point left or right to the number of places equal to the difference in the exponents. Okay, so if we are trying to find the difference between 0 and 3, I'm going to subtract 3 minus 0. That is a difference of 3 exponents. So what that means is we convert 5 meters and we want to know what that value is in kilometers. I'm going to write out 5 right here. Here's my decimal point. I'm just going to actually leave that there. So 5 meters, we know we need to move that decimal point 3 units. We are going from small to big, which means that decimal point is actually going to be moved 3 decimal places to the left. So we're going to say 1, 2, 3. Our new decimal point is going to be right here. I apologize, I'm going into these notes, so if this is hard to see, again, I apologize. We're going to fill in those units with zeros, and we get our final answer that is 5 meters is equal to 0. Again, I'm looking over this way so you all can see where I'm filling in my answer here. Is equal to 0.05 kilometers. So again, we took that decimal place from 5, we moved it 3 places according to this difference here to get our final answer of 0.005 kilometers. That's just our example here. So again, hopefully you all had a little bit of space to write that example next to those steps there, but I did want to show you an example for how you would use those steps to convert between units of measurement. So at the end of this, after recording all of your notes, I recommend writing a summary and using these essential questions and answering those in your summary. Write a summary of what you learned from these notes today. And I look forward to discussing this with you all in class.